Most Significant Bit podcast, a show created by students at Purdue Polytechnic to explore connections between engineering, arts, and humanities. I'm George Dhoore, your host for this episode, and today we'll be talking about artificial photosynthesis. Photosynthesis. We've all heard the word and have learned the basics in our 6th grade science class. Photo from light and synthesis from the making of something new from simpler parts. It's how plants make food and turn carbon dioxide into oxygen, we were told, but the potential is far, far greater. Yes, plants use photosynthesis to make sugars, starches, and oxygen, but what if we can harness similar processes to make other chemicals on an industrial scale? What would that look like? What benefits would we see as a society? We may not have to wait much longer to find out. There is extensive research going on right now into a category of chemicals known as photocatalysts. Catalysts are chemicals that increase the rate of chemical reactions without being consumed in the process. A photocatalyst is simply a catalyst that is powered by light. Why is this so important? Out of all the commercially produced chemical products, 90% of them use a catalyst somewhere in the process. Common catalysts are platinum, palladium, iridium, all incredibly expensive and precious metals. What's worse is that these catalysts often require very high pressures and temperatures to function optimally. This high energy cost is often associated with high carbon dioxide output, which contributes to global climate change. The chemical industry alone generates almost 1 billion tons of carbon dioxide emissions annually. The photocatalysts under research and small-scale production right now are much cheaper and can usually function at room temperature and normal pressures. This opens the door to carbon-negative processes that can take carbon from the atmosphere and fix it safely into a product. One company pioneering a class of organic photocatalysts is New Iridium. New Iridium's photocatalysts are capable of speeding up several important chemical reactions, such as the Birch reduction and dehalogenation, among others. A primary product New Iridium is targeting is carboxylic acid, which uses carbon dioxide as a feedstock. Now, because these reactions are done at low temperatures and pressures, every ton of carboxylic acid created sequesters more than half a ton of excess carbon dioxide, making the entire process carbon negative. While this is impressive alone, one of the goals of New Iridium is to create the natural gas methane in a closed carbon loop. Being able to take the carbon required for methane directly from the air ensures that no new carbon dioxide is being released into the atmosphere. This in itself doesn't make the creation of methane carbon neutral. For every carbon atom, methane also requires 4 hydrogen atoms. Luckily, the other big process that photocatalysts are being investigated for is the splitting of water, H2O. If we take the C from CO2 in the air, and the H from H2O in the oceans, all we're left with is the O, oxygen, fresh air from artificial photosynthesis. What does a future with widespread artificial photosynthesis look like? Imagine gas prices that fluctuated on the amount of sunlight instead of the amount of oil produced. Imagine fewer power plants as more chemical processes are powered directly from the sun. Or imagine a concerted effort to green the deserts of the world because of the ideal amount of sunlight and what that infrastructure might do for the solar power production of electricity. Simply, imagine a brighter future through biomimicry. This has been The Most Significant Bit. I'm George Dhoore. Thank you for listening.